Okay folks, welcome back. So another video in this series where I am using RStudio to conduct data science tasks and do some data analysis. So this is video 15 and it's the second video in this series where I'll be doing some sort of data visualization. So in the last video I started off simple with some visualizations, how to create a scatter plot. In this video what I will do is show you how to use ggplot within the tidyverse to create histograms. So histograms are a really useful way to present data. So in their simplest form, they're used to plot the distribution of scores on a single numeric variable. So on the x-axis we've got the scores on a numeric variable, and on the y-axis we've got the frequency count of those scores, the number of observations, or the proportion in some cases of observations that have that particular score. So they're useful for seeing how a variable, how your data is distributed. Okay, so I'm going to use a built-in data set to demonstrate this particular in this particular video how to create a histogram. So first of all, what I'm going to do is I'm going to import the tidyverse. I've already got this installed, and if you've watched any of the previous videos, you'll know that it's kind of a really useful umbrella package, and it's got a number of things for tidying and visualizing data within the tidyverse. One of them being ggplot, which is a really useful and probably the main package for creating data visualizations within R and RStudio. Okay, so that's worked. You can see if you look in the console below, it shows you which packages the tidyverse. I've loaded the tidyverse, and you can see which packages have been loaded along with it. And we've got some conflicts here because we got function names or function calls that are shared by different packages, so it's telling us about potential conflicts. Nothing for us to particularly worry about here. One thing I should note, actually, one thing I should mention from the previous couple of videos, I wasn't working, so I had some issue with some sort of corruption around the project that I was working in. And the last few videos I hadn't created a project. I wasn't using a particular project to store all the different scripts I was using. But what I have done is I've gone back and created a new one to keep things tidy. So the R project creates this nice little sandboxed environment where you can keep all your scripts relating to a particular piece of analysis or research or something like that. And you can see, if you look up here where my cursor is in the top right, you can see the project is shown as R data wrangling. The last few videos, if you look, I was having to set the working directory manually because I wasn't working in a project. And you can also see here, if you look on this top line above the console, you can see the actual path. So I've got this R data wrangling project saved within this R data wrangling and visualization folder. Okay, so that's just a little bit of housekeeping, but I've loaded the tidyverse. A command you can run is data with parentheses, and if I do that, what it'll do is it create this pop-up, and it'll show you all the built-in data sets that are available within R, and there's an awful lot of them. It's just worth knowing about in case you're looking for some sort of particular data set in relation to something just to run analyses on. So I'm going to use one that I'm going to use is called msleep. So it's a data set recording the amount of sleep different mammals have on a daily basis. It's got a number of different variables recorded, so categorical variables around species and genus and things like that, and also numerical variables around the length of time awake, length of time of sleep, such like. But I'm going to use this command where I'm putting a question mark and then the name of the dataset msleep. If I do Control and Enter on that, what that will do is in this help window down here is kind of give us a load of information. So it's msleep, it's contained within the ggplot package, it's a built-in data set. It tells you who created this data set, who collected it. It's from some sort of PNAS research around the amount of time mammals spend asleep. There's 83 rows and 11 variables. So let's have a look at that using the view function. So using view and then in parentheses I'm passing the name of the data set. And you can see there, just like, let me make this slightly bigger. There we go. You can see there we've got a few different variables. Some are numeric, such as body weight, brain weight, and awake. This is the amount of time awake. We'll use this to analyze something or to create our plot in a second. Total sleep, I guess that's hours. Species, the order, that type of thing. So pretty interesting. Data set and a useful one to play around with. So what I'm going to do is just kind of create some histogram plots for one of those variables, which was the awake variable. I guess that's the number of hours that different species are awake, or mammals are awake generally. So if you remember from the previous video, we started using ggplot, and I told you there are 3 things that you need to supply as kind of arguments when you're using ggplot. So you need to tell it what data to use, you need to tell it what mappings, so what variables to map on the x and y axis, etc. And then you need to provide some sort of geometry or geome, telling it how to present the data, so using points, using lines, that type of thing, using bars. So this here, lines 15 and 16, you can see I've kind of followed a similar format to the one we used for the scatter plot in the previous video. I've called ggplot, in parentheses I've specified the data, put a comma, I've specified the mapping, and that's the aesthetics, the AES. And I'm saying, in this case, I'm not specifying a y variable because I'm creating a histogram, the only thing I'm interested in is plotting one single numeric variable to look at the distribution of it. So all I have to do is specify y1 plotting on the x-axis, and I've said on the x-axis plot the awake variable, so number of hours awake. Plus, remember the plus has to come at the end of the line, and then I'm saying geome underscore histogram. So to know that you use this to create a histogram or geome scatter plot, to create a scatter plot, you need to go to the, sorry, I got pop-ups on my computer. You need to go to the ggplot documentation. There's plenty of documentation. You can see all the, it's not possible for me to kind of demonstrate all the functionality, all the different arguments you can use in these videos. So when you're doing data science, when you're wrangling data, when you're analyzing data, you're going to have to get into the habit of going to the documentation to find out what arguments you might need, how to set up your syntax, so to speak. So plus geome histogram, so I'm saying what histogram, I'm specifying this bin width argument. So this is how wide the bins are. So the data on the x-axis is numerical, and we're dividing it up into 2. So every 2 units, essentially, anything falling within 2 units will be counted within the same bin. I'll demonstrate later if we do. I've specified this because it gives us a good impression of the distribution of the data. You can change that. It's very easy with histograms to fool yourself as to the distribution by changing the bin width. We'll see what I mean by that when I run a similar call later, and we kind of just let it be the default bin width, essentially. So I've specified set a bin width for 2 for the histogram, so that anything falling within 2 of each other will be counted within the same bin. I think essentially we're putting them into buckets, so to speak. And then I've specified this fill argument. Fill is the color of the bars on the histogram, essentially. What color we want it to be, and I've just found this hex. I used a hex code picker online, and I found this hex code. So hash FF and then 4 zeros will give you a red color. So let's run that and see what it looks like. And oh gosh, that's garish, that red color, but okay, pretty good. So you can see here you get the general impression how this works. And it's created a nice plot for us, so we can see we've got awake plotted on the x-axis. It goes from 0 up to kind of just above 20, maybe around 22, 23, something like that. And the y-axis in this case is showing like frequency counts, numbers falling into these bins. So each of these bins here, you can see they're going to be anything within 2. From anything from say 5 to 7 here will be counted within the same bin, so to speak. And there's kind of, looks like there are about four mammals, let's say, that have an awake number of hours awake between 5 and 7 hours. Yeah, and then between 7 and 9, it looks like we've got 5. Yeah. Okay, so that's kind of that's the simplest way, a very simple histogram. What I thought I would do in this video, though, whilst we're at it, is we've looked previously at the tidyverse using the pipe operator to specify our tidy our data and select the things we want in a very intuitively easy to understand grammatical way. We can combine those pipe operator calls in the tidyverse with our ggplot calls, essentially. So in the call above, highlighted still on lines 50, I've said ggplot, and then I've specified the data, and then I've specified the aesthetics, and then the geo. We're going to do something similar here, but first of all, I've specified the data. I've not had to say data equals. I've just specified the data set, and then I've piped that in to ggplots. I've used the pipe operator. I've said use the msleep data, and then you use ggplot to create a plot. The mapping is going to be awake on the x-axis, and the geometry is going to be a histogram. Okay, and I've added some. So this section here is pretty similar to the syntax above, except we've moved data. We've specified our data before we've specified the call to ggplot. But then I've added this extra argument just to demonstrate some functionality. I've added another plus, and I've put labs as an argument. So labels is what we're adding here. So what I'm doing is to make this look a bit more tidier, a bit more professional. I'm specifying as a string here. On the x-axis, I want it to say total sleep. On the y-axis, I want it to say frequency count. And then I've also said, give it a title saying distribution of time awake in mammals, something like that. Okay, so let me run that. And I've chosen a different fill color as well there, because red was a little too. There you go. That looks good. And immediately we're getting a plot that's a histogram that looks much more professional and tidy. We've got our labels, and we've got kind of some nice and a reasonably nice color scheme. Okay, so pretty straightforward, really. The geom we need to plot a histogram is geom histogram. And the other calls when ggplot are the same. We have to specify the data we want. We have to specify the aesthetics, and we can sort of embed our ggplot figures within kind of some piping operations where we kind of, you know, this could be much more complex. It could be the case where we wanted msleep data, and then we wanted to tidy the data, and then we wanted to plot the data, and we could do that all with pipe operators and then calls to ggplot, all in one block of code, essentially. So pretty cool, pretty useful. Okay, so one last thing that I was going to demonstrate here is noticing the calls previously. I've specified the bin width argument, and I've specified the field color as well, just kind of to make them look neater, and to pick a bin width that I think was pretty reasonable for this data set. What I'm going to do here is I'm going to run the same code as above. I've changed this y-axis. I've changed the label. I had the label on the y-axis as frequency count. I've taken it out just to save a little bit of space. It just means where I've put null here, all it means is there won't be a label on the y-axis. But the main thing I've changed with this particular block of code is I've taken out the parameter arguments here in geom histogram. So I've taken out the bin width and fill arguments. And we'll see how that changes the plot, essentially. There you go. You can see now that we're getting a bit more granular, and the data, when we change the bin width, the data looks slightly different. Okay, so as I said before, histograms useful for visualizing the distribution of data, but it is easy to fool yourself. And it is also easy when using default settings to get the wrong impression about the distribution of a particular variable. So you can see here we've got, if the default here I assume is going to be 1, where we've for bin width. So you can see here that, you know, we've got a much more ragged and less normally distributed set of data than it appeared in our previous plots there. That doesn't mean this distribution is wrong, just to give us an overall impression of the distribution of the data, but it's important not to fool ourselves. That's why it can be useful to overlay continuous kind of distribution lines on top of histograms. Right, so that's it. I think that's enough for this video. So that's it. That's all I was going to cover in this video. Histograms, useful when they're most basic. They are useful for plotting the distribution of scores on a single numeric variable. I've used that built-in data set to do that here, and I've shown you a couple of ways to create a histogram in ggplot using this kind of traditional kind of syntax where we specify data mapping and the geomes, and then using the same thing, but you also incorporating some elements of the tidyverse pipe operator as well to kind of specify what we're trying to do in a more logical and intuitively easy to understand sequence. Okay, all right guys, hope this was useful. Thanks for watching and listening, and I'll record another video soon.